Hello dear students, welcome back to our physics class. As you know, in a previous lesson, so we stop it here, question 33 from chapter review. The question says a 13,500 Newton car. What is this? This is the gravitational force of the car, Fg, which is equal to what? Is equal to 13,500 Newton. Traveling at 50 kilometers per hour. What is this? This is the tangential speed, which is given in kilometer per hour. Okay, so is it possible to solving with the kilometer per hour? No. So that is why you have to convert to what? Meter per second. How can you convert to meter per second? Multiply by 5/18. Okay, so Vt is equal to what? Is equal to 50 times 5/80. Always to convert kilometer per hour to meter per second, you have to multiply by what? The given value by 5/18, which is equal to 13.9 meter per second. You have to use this value of tangential speed. Round the curve of radius. The radius of this curve is given is equal to 2 times 10 power 2 meter. 2 times 10 power 2 is equal to 200 meter. Okay? Find the following. The centripetal acceleration of the car. AC. AC is unknown. A. Branch A. Okay? How can you determine AC? AC is equal to Vt squared over R. Do we have Vt? Yes. But Vt was given in kilometer per hour. After conversion, it becomes 13.9. So that is why we have to use 13.9 squared divided by 200, which is equal to 0.966 meter per second squared. This is centripetal acceleration for this car. Branch B, the minimum coefficient of static friction. If you see this statement, coefficient of static friction is equal, it means that mu is. If the minimum coefficient of the static friction is unknown between the tires and the road, that will allow the car to round the curve safely. So mu s is unknown. Branch B, what is unknown? Mu s is unknown. How can you determine mu s? Because the question said the car traveling in the round curve. This is car, this is not cylinder. As I mentioned in a previous lesson, when a car is moving in a circular path, the static frictional force provides the centripetal force. So that is why Fc is equal to Fs. And is equal to what? Mu s is equal to AC over G. Okay, AC over G. We proved this equation, okay? If you want, I'm gonna prove again, okay? Because maybe the students ask us, how can we get this equation? Because mu s, look at me, I'm gonna prove again. Mu s is equal to what? Is equal to Fs over Fn. But when a car is moving in a circular path, the centripetal force provided by Fs and Fg is equal to Fn. Okay? So instead of Fs, is it possible to write down Fc? Yes. Fn is equal to what? Fg. Fc, Newton's second law for circular motion, is equal to mac. Fg, gravitational force, is equal to mg. Mass with mass cancel. What is remain? Mu s is equal to AC over G. Do we have AC? We didn't have, but we found it. 0.966 divided by 9.81 is equal to 0.098 unitless. What is the unit of coefficient of static friction? Is unitless. Why? Because it's the ratio between two forces. Is the ratio between two identical physical quantity. Newton cancel. Okay? such as the index of refraction that we studied in grade 10, which is equal to speed of light in vacuum divided by the speed of light in a given medium. Okay, so this is the how you can determine the coefficient of static friction when a car is moving. But in the case when the question is about the cylinder, rotated cylinder, for rotated cylinder, mu s is equal to what? Opposite of the mu s in car when it's moving in a circular path is equal to Fg over AC. Okay? This is question 33. If you want, you can screen this solution. Okay? So already all the questions are solved in this pamphlet, in this book, okay? But I would like to solve all the questions one by one. Why? Because to show you the steps, how can you solve the solving question in physics. It's very important, okay, to solving the questions and solving the questions very precisely, okay? The coefficient of the friction is unitless, as I mentioned, okay? Question 34. 2 times 10 power 3 kilogram car. What is this? This is the mass of the car. Mass is equal to 2 times 10 power 3 is equal to 2000 kilogram. Okay? Around the circle turn of a radius, the radius of this car, as you can see in this picture, the car is moving in a circular path. The distance from the axis of rotation is 20 meters, or is 20 meters, okay? If the road is flat and the coefficient of static friction between the tire and the road is 0.7, what is this coefficient of static friction? 0.7, okay? How fast can the car go without skidding? What is unknown? Vt is unknown. Okay, at first you have to write down the given value and the hidden value. Okay, what is hidden here? The tangential speed. How can you solve this question? Because we have 3 equations which is related with the coefficient of static friction. The questions say car round is a circular path. For a car when it is moving or rounding in a circular path, how many equations do we have for mu s? We have 3 equations. The first one, AC over G. The second one, Vt squared over Rg. The third one, omega squared R over G. We proved all the equations. Which equation can be used from these equations? Equation number 2. Why? Because the speed is unknown. So we have to choose which one? Equation number 2. This is 1. This is 3. Why equation number 2? Because the question says find tangential speed. Because the tangential speed, we have tangential speed in equation number 2. That is why we have to select equation number 2. Mu s is equal to what? Vt squared over R times G. Okay? If you cross product, 1 times Vt squared, rearrange equation. Mu s times Rg, mu s times R times G. The question said find the tangential speed, or what, how fast, not find the square. So that is why we have to remove the square. How can you remove the square? Multiply by radical. So Vt is equal to what? Mu s times R times G. Okay, so replace. Mu s was given 0.7 unitless times R, distance from the axis of rotation or the radius of the circular path, also was given. G already is constant, which is equal to 9.81. So by calculator, Vt is equal to what? Vt is equal to 11.7 meter per second. So this is question 34 from chapter review, and very good question, mechanical. Okay. Question 35 in chapter review. Question 35. A copper block rests 30 centimeter, okay, from the center of the steel turnable. What do you mean by from the center of the steel turnable? Okay, this is the copper block, okay. This is from centimeter from the center of the turnable, okay. So which is R is equal to 30 centimeter. You have to convert to meter divided by 100. Why? Because the SI unit of the radius is meter, 0.3 meter. The coefficient of static friction between the block, which is the static coefficient, static friction force, Fs provided Fc is equal to 0.53. Mu S is given 0.53. Okay, so this is the same case of the car when it's moving in a circular path. The turnable starts from rest. What do you mean by turnable starts from rest? It means that omega initial is 0. Why? Because it started from rest. And rotates with a constant angular acceleration. Constant angular acceleration means that alpha. How did you know this is alpha? Because the question mentioned, and also by the units you can recognize. Rad per second square is the unit for what? Angular acceleration, which is equal to 0.5 rad per second square. After what time interval? What do you mean by after what time interval? It means that delta t is unknown. Okay? Delta t is hidden here. So the normal force in the case equals the weight of the block. So we have a hint here. What do you mean by normal force equal to the weight? It means that Fn is upward, Fg is downward. So that is why the block of the steel block is maintained on the turnable. Okay. So in that case, how can you determine the time interval? So you have to make a plan to solving this question. Okay. How can you solve this question? At first, you have to write down the equation of time. As you know, alpha is equal to what? Omega final minus omega initial divided by time. To find time, if you rearrange the equation, change the position of time and the angular acceleration, okay, which is delta t is equal to delta t is equal to omega final minus omega initial over alpha. Okay. Do we have alpha? Yes. Do we have omega initial? Yes. Do we have omega final? No. Without omega final, you cannot finding delta t also. So that is why we have to finding what? Omega final. How can you find the omega final? By using the equation of the coefficient of static friction, which is equal to mu s is equal to what? Omega squared r times g. Okay, sorry, not like that. This AC over g, Vt squared rg, omega squared r times g, r with r cancel. Mu s is equal to what? Omega squared r over g. This equation can be used to find what? Omega squared. How? Because mu s is equal to omega squared times r over g, cross product. Okay? So the equation becomes like that. 1 times omega squared r is equal to mu s times g. What is unknown? Omega. Omega squared is equal to what? Mu s times g over r. Take the square root or radical to both sides. What is remain here? Absolute angular speed is remain, which is equal to mu s times gravity over distance of the from the center, from the axis of rotation, and the radical. Omega final is equal to what? Is equal to 4.16 rad per second. Replace into this equation. Delta T is equal to what? Do we have omega final? We didn't have, but we found it, which is equal to 4.16 minus 0. Why 0? Start from rest. Okay? And alpha was given 0.5. So delta T is equal to what? Delta T is equal to 8.3 seconds. Okay? So you have to make a plan to solving this question. At first you have to write down the equation of time. After that you have to find the omega final, because without omega final we cannot find the time. How can you determine omega final? Because coefficient of static friction is given here. So that is why we have to think about the equations of the static coefficient of static friction, which is equal to omega squared times r over g. Okay? Question 36 is about a popular amusement park. In a popular amusement park, write a cylinder. What is this? Listen carefully, please. Cylinder. In a cylinder, the situation is completely different with the car when it's moving in a rotational, in a circular path. Why? Because in cylinder, I'm going to repeat the equations. In cylinder, mu s all the time is equal to what? Fs over Fn. But, okay. In a question 36, in a popular amusement park, write a cylinder. Be careful. The question says cylinder. This is not car. The situation of the cylinder is completely different with the situation of the car when it's moving in a circular path. The radius of the cylinder is 3 meters. Okay? Radius is what? 3 meters. The distance from the axis of rotation. Okay? Set in a rotation at an angular speed. What is this? This is omega. Omega is given is equal to 5 rad per second. It's shown in this figure. The floor then drops away and leaving the rider suspended against the wall. The rider is suspended what? Against the wall. Okay, here. Fg downward, Fs is upward, Fn provides Fc. Okay? In vertical, what minimum coefficient of the friction between the rider's clothing and the wall of the cylinder is needed to keep the rider from sleeping? Okay? So there is a hint here. Fs is equal to mu s times Fn. So what about what is unknown? Mu s is unknown. How can you find the mu s? As you know, mu s is equal to what? Is equal to Fs over Fn all the time. But in the case of cylinder, Fs is equal to what? Fc. Why? Because in cylinder, Fc provided by Fn, Fg is equal to Fs. Okay? And instead of Fs, sorry. Fs is equal to what? Fg. Look, in cylinder, Fg is equal to what? Fs. What about Fn is equal to what? Fc. Fg, Mg, Fc, MAC. M with M cancel. What does remain? G over AC. Can I use this equation? No, because we don't have AC. So that is why we have to convert. AC is equal to what? Vt squared over R. Vt squared over R, but this R, it goes upward, becomes GR times over Vt squared, which is equal to G over omega squared R. Which equation can be used? This one. Mu s is equal to what? G over omega squared R. G constant. Omega was given 5 squared. Okay. time is the distance from the axis of rotation also was given is equal to 3, and mu s is equal to 0.131 unitless. Why unitless? Because it is the ratio of two forces. Okay, we finished it. All the questions which is related with the centripetal force. Okay, now let's get started solving and explaining the Newton's law of the universal gravitation. Okay, so it is very important, and many years the question has been brought about this topic. Okay, so that's why you have to listen carefully. Okay, guys. Newton's law of universal gravitation. So when a planet moves in nearly circular orbit around the sun, the force that keeps this planet from the coasting off or flying off in a straight line is what? The gravitational force. Which type of the force maintains or keeps the object or the planets in a circular path? The gravitational force between the planets. Without this gravitational force, the planets coast off in a linear path, or they cannot maintain in a circular path. So, and this force is a mutual. What is the gravitational force? It's a mutual force between two masses, and it is directly proportional to the produce of the object's mass and inversely proportional to the square of the distance. What do you mean by directly proportional to the product of the mass and inversely proportional to the square distance between the two masses? Means that Fg is equal to what? G m1 m2 over r squared. What is relation between Fg and the product of mass? Is directly proportional. What is the relation between Fg with the radius or distance between them in the upward directly? But here inversely. It's inversely proportional. Okay? This is directly. This is inversely proportional. When a mass increases between two objects at a given distance, at constant distance, what happens to the gravitational force? Also increases. Look, when masses are increases at constant r, what happens to the gravitational force? Also increases. But when the distance between the two masses increases at constant mass, what happens to the gravitational force? Decreases. For example, we have two given mass here, Earth and Moon. For example, when we separate farther from each other between the Earth and the Moon, or if the distance between them is bigger than now, what happens to the force? Decreases. Why? Because it is inversely proportional to each other. Okay? So Newton's law of the universal gravitation is a mutual force exists only between two objects, between two masses. Not between every two huge masses, even between any two masses, even electron and the proton, which is directly proportional to what? Product of the object's mass and inversely proportional to the square of the distance. Okay, so G is constant, which is equal to G is constant, okay, is equal to 6.67 times 10 power negative 11 Newton, negative 11 Newton meter square kilogram square. So the unit of the gravitation constant, it is very important, be careful. Okay, this unit of the universal constant is very important, this G. How can you prove this unit? In the case, for example, if you forget, you can prove that this equation. Fg is equal to what? Is not equal to G times m1 times m2 over r square. Okay, rearrange, cross product. What time is the denominator? Say G times m1 times m2 is equal to Fg times r squared. Fg times r squared. Now I'm going to prove the unit of the gravitational constant, okay, or universal constant of the gravity, which is equal to m1 and m2. It goes to the denominator. What is staying in the upward denominator? Fg times r squared. Okay. Now you can prove that G is equal to what? The unit is equal to Newton meter squared per kilogram. Fg measured in what? Newton. R meter. R square meter square. Mass kilogram. Kilogram times kilogram. Kilogram square. Also, you can write another units for the universal constant. Newton is equal to what? Newton is equal to kilogram meter per second square. And instead of this Newton, write down kilogram. Okay, we have meter square here, kilogram square here. But instead of this Newton, write down what? Kilogram meter per second square. Okay. So we have some shortcut here. Mass times mass. Mass cube kilogram with kilogram, kilogram with kilogram cancel. Meter times meter square, meter cube over kilogram second square. Meter cube, kilogram second square. If they bring in the Wizari exam, which of the following can be measured for the universal constant of universal gravitation? You have to say both Newton meter square per kilogram square or meter cube per kilogram second square. So what is the gravitational force? Gravitational force, the mutual force of attraction. The force is always attraction. Why? Because the mass of the object is always positive. The mutual force of attraction between particles of matter measured in Newton. Gravitational force acting such as that object that was always attracted to one another. So the Newton's third law states that the force exerted on the earth by the moon, okay, force exerted on the earth by the moon is equal to the magnitude of an opposite direction of the force exerted on the moon by the earth, which is equal to F-E-M, but in opposite direction. What does gravitational force depends on? The product of the object's mass directly and square separation. Okay, why? Because Fg is equal to what? Constant. M1, M2. What does gravitational force depends on? The product of the mass and the square separation, which is inversely proportional. Newton's third law, as I mentioned before, the force exerted on the earth by the moon is equal and opposite direction to the force on the moon by the earth. Okay? So the planet moves in nearly circular orbit around the sun. So the force that keeps this planet in this circular orbit is the gravitational force. Such as orbiting Earth around the sun, the gravitational force provides the centripetal force. Note number 2, the gravitational force is a field force, non-contact force that always exists between what? Between two masses, regardless of the medium that separates them. The gravitational force exists not just between the large mass or huge mass such as sun, earth, and moon, but between any two masses, regardless of the size or the composition. Number 4, the gravitational force is directly proportional to the product of the object's mass, and the gravitational force is inversely proportional to the square separation. Or you can say directly proportional to the inverse square of separation. Why? Because if F inversely proportional to r square, you can take this r square to the denominator, it becomes inverse. And also you can say gravitational force is directly proportional to the inverse square of separation. Be careful. Which of the following is correct about the gravitational force? The gravitational force is that A, gravitational force is directly proportional to the product of the mass. Yes, this is true. Gravitational force is inversely proportional to the square distance. Also, this is true. C. Gravitational force is directly proportional to the inverse square separation. Yes, also this is true. So the correct answer is D, all of them. Okay? Mass doesn't change according to the location, while weight changes by changing location. Why? Because the mass depends on the number of particles, decreases and increases by increasing and decreasing the number of particles. But weight is a force, is the gravitational force, which depends on the location and the mass. Okay? The gravitational force is a field force, as I mentioned. Kepler suggested that the planets revolve around the sun in the elliptical paths. Which of the following scientists they suggested that the planets revolve in an elliptical path? Johannes Kepler. Be careful. Even though the scientists continue to believe that the Earth is the center of the solar system, until Sir Isaac Newton was able to derive the elliptic path, and suggested by the Kepler using the law of the Johannes Kepler. According to the Kepler third law, we can find the orbital speed. This orbital speed is very important. Be careful, guys. For example, assume that this is Earth, okay, and this is an artificial satellite. What is this? This is artificial satellite. Okay, when this artificial satellite is orbiting around the sun, there is a separation with the Earth. Okay, so there is a separation, okay, with the Earth, and this is R, okay, the center of Earth, and the artificial satellite is moving with a tangential speed, and also it has the angular speed, okay? So how can, this speed is called the orbital speed. What this speed is called? Call it orbital speed. How can you prove this orbital speed? How many masses do you have? M small represents for the mass of the satellite. M capital is the mass of the Earth. So what forces keeps the satellite from being ejected in the circular path? The gravitational force. Between what? Between Earth and satellite. Fc provided by what? By Fg. Fc is equal to what? mv square, mvt square over r mg. Mass, sorry, which is Fg is equal to what? G m. Okay, Fc provided by what? By Fg. Fc is equal to what? mv square, vt square over r, was equal to G times m of the satellite times f of the Earth, mass of the planet, divided by what? R square. R with R cancel. Mass cancel. What is this? This is the mass of the satellite. Okay? What is remain? Listen carefully, please. Vt square remain here. This Vt is called orbital speed, which is equal to what? G times what does remain here? Remain here? The mass of Earth divided by what? By R. Time is radical. Okay? It becomes what? Vt orbital. Radical what? Universe constant, mass of planet, divided by what? The distance from the axis of rotation, or the distance between the satellite and the Earth. So, this equation can be used for every planet which is moving or orbiting around the sun. Okay? So, we can conclude that the tangential or the orbital speed of the planet or the artificial satellite depends on two factors: the mass of the planet and the distance between them. Okay? Look, this is The equation Fc is equal to Fg, mv is equal to r. This is what? Orbital speed. Orbital speed is equal to what? G constant, mass of planet. What is this m capital? Mass of planet, please, divided by the radius. And also you can find in the period, which is equal to 2 pi r cube over g m. And we will study the period in chapter 3, okay? So to find the orbital speed and orbital period of the satellite's orbit or the orbiting Earth around the sun or the planet, we need what? Mass of the planet? Mass of planet or mass satellite? Mass of satellite, mass of the planet, be careful. Orbital speed depends on what? Mass of satellite or mass of the planet? Mass of planet. And the radius of the orbit. If two gravitational forces and two separation distances are given, you can use this relation. Okay, very important relation because gravitational force is inversely proportional to the radius or distance between them. So that is why Fg1 over Fg2 is equal to R2. If this is 1, it should be 2. Why? Because they are inversely related over R1 squared. Comment on the statement, there is no gravity in the outer space. This statement is wrong. Why? Because the gravity is very weak since the distance between the object is very high. What is relation between Fg and distance? Is inversely related. More or less gravitational force. But we cannot say there is no gravity. There is a gravity, but it is too weak. Okay? So that's all for today. Inshallah, in the next lesson we will continue and we will finish the chapter 1 and section 3. Okay? Hope you get benefited and thank you for listening.